Hello friends, welcome to Learner's Planet. Friends, I'm here with one more session of permutation and combination. In the last session, we discussed some of the multiple choice questions like basic, easy multiple choice questions. So we'll continue taking more multiple choice questions based on permutation and combination in this session as well. So let's begin the session, and I hope you might have revised the previous session so you'll feel comfortable in this session. Right? So let's begin. Now friends, let's take this question. The number of ways of arranging 6 people having A, B, C and D among them in a row so that A, B, C and D are always in order A, B, C, D, not necessarily together. That means A has to be before B, B has to be before C and C has to be before D, right? Quite a simple problem and interesting one. See, we have to arrange 6 people, so let's first make 6 places. 1 2 3 4 5 6, right? On the six places we have restrictions for A, B, C and D, right? So what we do, from this 6 places we select the 4 places, right, in 6C4 ways, right? Now we have selected 4 places for A, B, C and D, right? In this selected 4 places, there is single possibility of arranging A, B, C, D, that we have to make them sit as A, B, C, D, right? This order should be there. Maybe the places are like whatever the places, maybe this, this and this. But A will be before B, B will be before C, C will be before D, not immediately before but before. Yeah. So what we do, we selected 4 places for A, B, C, D and make them sit in just a single way, right? Now we are left with the 2 places and 2 people. So 2 places, 2 people, they can sit in 2 factorial ways, right? So simply this is 6C4 into 2 factorial. So let's calculate that. 6C4 is what? 6C2. So 6C2 is 6 into 5 by 2 into 2. So it is 30 ways, right? As simple as that, right? So what is a mistake which is done over here? We select 4 places out of 6 places, but simultaneously we make 4 factorial also, right? So all the arrangements like come into effect, but there is a single possibility according to the condition of the question that A should be before B, B should be before C, C should be before D, not immediately but before E. Yeah. So I hope you are clear. Now friends, let's try this interesting question. Let A be such that x is a prime number and x is less than 30. The number of different rational numbers whose numerator and denominator belong to A is. That means we have to find out how many numbers are there where numerator and denominator are prime numbers, right? So first of all, how many prime numbers are there? I just write it over here from like less than 30. So it's 2, 3, 4, I'm sorry, 2, 3, 5, then 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 19, 20, 21, 22, 23, 24, 25, 26, 27, 29, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In all, 10 prime numbers are there. Now, see, we have two options. Since we have to find out different rational numbers, first of all, what we do, we choose two different numbers from these and we arrange them in the position of numerator and denominator, right? Okay. We cannot choose two same numbers because in that particular case the number will become 1. If the numerator and denominator is same, the number will become 1, right? So first case, what we do, we select two numbers out of this 10 numbers. So it's 10C2, right? Now till here we have selected two numbers, right? Now these selected two numbers can be arranged in numerator and denominator, right? So we are having two ways to arrange them. So it's 2, right? Now what is 10C2? That is 10 into 9 by 2 into 2. So there are 90 ways of doing this, right? So in all, 90 numbers we will be getting, plus one more number will be getting, that is 1, right? If each prime number is divided by the same number itself, so we'll be getting 1, right? So we will be getting 10 times 1, but we have to find out the different rational numbers, so we'll be just calculating that as a single one, right? So 90 ways plus 1, that is in all we will be getting 91 different rational numbers, right? Examples are like 2 by 3, 3 by 2, right? If they are mutually arranged. 4 by, 5 by 7, 7 by 5, right? Similarly, 7 by 7, 11 by 11, something like that, right? So first of all, what we did do, we selected two prime numbers out of 10 and arranged them in two factorial manner. So the numerator and denominator in all these cases, that means in 90 cases, the numerator and denominator are different, because while we are doing 10C2, two different numbers will be selected definitely, right? After that, we added 1 because we will be getting 1 also if I divide each number by the number itself, right? So in all 91 different rational numbers we will be getting. Okay, so it's really an important and an interesting problem. I hope you are clear with the concept. Now friends, further we have an interesting problem. Let A be the set of 4-digit numbers A1, A2, A3, A4, where A1 is greater than A2, that is greater than A3, and that is greater than A4. Then NA is equal to, that means we have to find out the total number of 4-digit numbers when all the digits are in descending order, right? So pretty easy question, but interesting as well. See, we have total 10 choices of the digits, right, from 0 to 9. Now from these 10 digits, we have to select 4 digits so we can make 4-digit numbers, right? So we selected 4. Now what? See, we selected 4. Definitely the 4 digits will be different from each other, right? Maybe whatever the digits are, but they will be different from each other, right? Because we are selecting 4 different digits. Now, if we are having 4 different digits, so there will be a single way of arranging them in descending order. Just single way, isn't it? Suppose we selected 2, 3, 0, 1, right? Now there is a single way that we can arrange the numbers in descending order. Now what's that way? 3, 2, 1, 0, right? So we selected the 4 numbers out of the 4 digits out of this 10 digits, and we arranged them in descending order in just one way, right? So this is our answer is like, this is the whole concept is, right? So 10C4, that is 10 into 9 into 8 into 7 by 4 factorial, that is 4 into 3 into 2 into 1. 4 2s are 8, 3 3s are 9. So 3 7s are 21 into 10. Total 210 numbers will be there of 4 digits. In all of these numbers, the digits will be arranged in descending order, right? So what the important part over here, you selected the 4 digits, but there is a single way of arrangement of all the 4 numbers in descending order, right? So I hope you are clear. Now friends, let's see this problem. 10 persons are arranged in a row. The number of ways of selecting 4 persons so that 2 persons sitting next to each other are selected. No 2 persons sitting next to each other are selected. So what we do is, we arrange the 6 people, 1, 2, 3, 4, 5 and 6, right? Now we have to select the remaining 4 people from these positions, 1, 2, 3, 4, 5, 6, 7, right? So if we select the persons from these position, that is this and this positions, so the person will not be next to each other, right? So how many positions do we have? 1 2 3 4 5 6 7. So we have 7 positions and we have to select 4 positions, since we want to select 4 persons only, so it's 7C4 ways, right? Now we just have to select, we don't have to arrange, so we won't go for any sort of any other calculation, right? So 7C4 is what? 7C3, and that's 7 into 6 into 5 by 3 factorial, that is 6. So in all there are 35 ways of doing this, right? I hope you are clear. Now The number of times of the digit 3 will be written when listing integers from 1 to 1000. Nice question. So friends, there will be three cases, right? Number 3 is written at one place, at two place, and at the three places, right? So we discuss each and every case one by one. First case, 3 is written once. So we have three places, up to three places. 1, 2, 3. So for the first place, suppose 3 is at the first place. So we just have one choice, right? If 3 is just written once. Now at the second place we have 9 choices, right? Except 3, any other number can come, right? Similarly here 9 choices. So in all it is 81, right? Now if suppose this 3 is at the second position, so here we have one choice, here we have 9 choices, except number 3, any number can come, even 0 can come. If 0 is there, we'll be getting 2-digit numbers, right? So we have 9 choices over here and 9 choices over here. So further it is 81, right? Similarly, if suppose number 3 is over here, then for this position we have one choice, for here 9 and for here 9. So further we have 81 choices, right? Now this is the total when 3 is coming for one time, right? So it's 243 ways, right? Now if suppose 3 is coming for two times, 3 is written two times, right? So we have further three places. From these three places we are selecting two places, right? In the two places we are going to arrange number 3, and for the remaining one place we have 9 choices. That means any number from 0 to 9 can be arranged, right? So it's 3C2 into 9, or we can say 3C1 into 9, or 3 into 9, that is 27, right? So we have 27 numbers with 2 times 3, and that means 3 is at the two places, right? That means in all we have 27 into 2, that is 54 threes, right? 243 threes we had here, 54 threes we have here. Now if all the three digits are 3, that means one more number, that is 333 we have. So in that particular number there will be three threes, right? So it is 333 is 54, sorry. So 4 and 3 7, and 3 10, 5 and 4 9, 0. So in all, if we write from 1 to 1000, we will be writing 3 for 300 times, right? I would just repeat. In the first case we took 3 for one time, so we got 243 numbers having 1 3, that means 243 times 3 we are getting. Then 3 is written two times, that means 27 numbers having 3 for two times. So in all 54 threes will be there. Then a single number, that is 333 is there, in which 3 is written for three times. That means we will be getting 3 threes. So in all 300 threes will be there if we write from 1 to 1000, right? Now friends, let's try this question. Let Tn denote the number of triangles which can be formed using the vertices of a regular polygon of n sides. If Tn plus 1 minus Tn is 21, then we have to find out the value of n. Now friends, we have already discussed that it takes 3 known collinear points to make one triangle, right? And now it is a polygon of n sides, that definitely the 3 points will not be collinear, right? So what we will be getting, how many triangles we will be getting, that is nc3, right? Now let's fill up the value in this given equation or given relation. See, if n plus 1 sides are there, we will be getting n plus 1 c3 triangles minus nc3, that is 21. Now we have to solve this equation. Now there are two ways, either we solve the equation it will form a quadratic equation, or what we can do is we can put the values from the option and get the answer, right? So I just discuss both the methods. First of all, n plus 1 c3 is what? N plus 1 n minus 1 and this by 6, that is 3 factorial, and minus this n minus 1 n minus 2, and this 6 whatever I'm getting in the denominator will be multiplied to this 21, and that will give 126, right? Now we can take n minus 1 as common. Inside that is n plus 1 minus n plus 2, right? N plus 1 minus n plus 2, so it's 3, and that is 126. So it's 42. Now n and n minus 1, these are two consecutive numbers, and product of these consecutive numbers is 42. So it must be 7 into 6, that's 42. That means n is equal to 7, right? Or you can choose the values from the options and put it over here and get the answer, right? Either way you can go, right? This is also like small method. You won't take much time if you are conceptually clear, right? So n is equal to 7 is the correct answer. I hope you are clear. Now friends, we have an interesting and twisted question. The sum of all the numbers greater than 1000 formed by using the digits 2, 4, 6, 8, no digit being repeated in any number is. Now, all the numbers are greater than 4000 and we have to use all the digits for ones only. That means precisely we have to calculate number of 4-digit numbers, right? And all the numbers of 4-digit we have to add up all of them and get the answer, right? Now what's the first step? That is, first of all, let's calculate how many numbers will be formed. Since we have to use each digit for ones, that means in all from 4 digits we will be getting 4 factorial numbers, right? So total numbers are 4 factorial, or we can say it's 24 numbers will be formed, right? Now friends, before we proceed, I just take a smaller example so this concept is clear in your mind. See, suppose I have 3 numbers, that is 1, 2, 3, right? From the mutual arrangement with these 3 number digits, we can make 3 factorial, that is 6 numbers, right? Just listen to me carefully because it's going to be an important concept which we are discussing over here and will be applying over there, right? Now I just write down all the 6 numbers, that is 1, 2, 3, 1, 3, 2, right? Then 2, 3, 1, 2, 1, 3. Then 3, 1, 2, 3, 2, 1, right? These are the all 6 numbers which I have written over here. That's I'm getting by arranging the 3 digits 1, 2, 3, right? So I'm getting this 6 numbers, right? Now just observe a thing very carefully. Suppose I have to add up all these 6 numbers. How do I do that? See, I'm not going to write all the numbers every time. 6 is a smaller number, so I have written, but in this case we have 24 numbers, so it will take a lot of time to write all the 24 numbers, and bright chances are that we miss out some number, or may we repeat any number, right? So obviously there should be some logic for doing this, right? Now what's that logic? See, we are getting 6 numbers and we are having 3 digits. In this case particularly I'm talking about, we are having 6 numbers and we are having 3 digits. That means 6 divided by 3, that is 2, right? That means each digit will come 2 times at each place, right? But obvious, we have 6 numbers and we cannot be partial with any of the numbers. So we have 6 numbers and 3 digits. That means each digit, and we are getting 2. That means each digit will come 2 times at each place. We can observe this. Just a moment. Just look at number 3. 3 is at 3 is 2 times at units place, then 3 is 2 times at the tens place, and 3 is 2 times at the hundred place. Similarly all the other numbers, right? Now how it is helpful for me? See, what I can do, I can add up all the digits at the units place, then tens place, and then hundreds place, right? Now since I know that each digit is coming 2 times at every place, so what I can do, just listen to me carefully. 3 is coming for 2 times at the units place. 1 is coming, 2 is coming for 2 times, and similarly 1 is coming for 2 times. That means 1 plus 2 plus 3, all this is coming for 2 times. That means 3 plus 2 plus 1, 5, 6 into 2, 12, right? So that addition of the unit place will be 12, right? That is 3 plus 2, 5, 6 and 6, 12, right? So what I'll do, I'll write 2 over here and 1 will be carried. Similarly, the sum of the second line, that is tens digit, will also be 12 because the same thing will be there. Each and every digit will come for 2 times, right? So I'll be getting sum 12 as well, and one I had carried from the units place, so the sum will be 12 plus 1, 13. Further, I would write 3 over here and 1 will be carried. The sum of these 6 number will also be 12 and 1 I had carried over. So 12 plus 1, 13. So the total of all these 6 numbers is 1332. Now the same funda I am going to apply over here for 24 numbers. Okay, so just listen to me carefully once again. Now what would happen? See, I have 24 numbers and 4 digits. That means 24 by 4, that means 6, right? So every digit will come 6 times at each place, right? Every digit will come 6 times at each place, right? So what will be the sum of unit digits? Just 6 times 2 will come, 6 times 4 will come, 6 times 6 will come, and 6 times 8 will come, right? So that means 6 times 2 plus 4 plus 6 plus 8, right? So that is the total of unit place, that is the total of tens place, that is the total of hundreds place, and that is the total of thousands place, right? Now what's that? 8 plus 6, 14, 14 plus 4, 18, and 2, 20, 20 into 6, 120. So 120 is the total of each line, that is tens, units, tens, hundreds and 1000, right? So first of all we add up the units place and we got the sum is 120. What I'll do, I'll put 0 and 12 will be carried. Now for the second line, the sum is already with me, that is 120, and I have a carried over, that is 12. So the total of the second line will be 132. Getting my point? So I will write 2 and 13 will be carried. Now for the third line, the total is still 120 and I have a 13 carried over. So it's 3, 2 and 1, 3 and 1. So the total of the third line up to third line will be 133. So I'll write 3 and 13 will be carried over. Similarly, the total of the fourth line is 120 and I have 13 carry over. So the total will be 133. And for the fourth place, I just have to write the data as it is, right? Because I don't have any carryover now. So this is the total of all the 24 numbers, right? Individual line total is 120, but when we add whatever the carried over from the units place, we transfer it to tens place, and carried over from the tens place is transferred to the hundreds place, and the carried over from hundreds place is transferred to the thousands place, right? So the same funda of addition we have applied, that we have been learning for years, and we got this total, right? Now let's match the answer from the options. This is 20 into 6, 120, so it's incorrect. This is 20 into 6, 120, 120, that is 12 into 1, 1, 1, 1 into 10. So that's 13320. So this is the correct answer, right? So the method which I discussed over here is like bit lengthy, but if you practice well, you'll be able to save some time, right? Alternatively, what we can do is, just listen to me carefully once again. So it looks like lengthy, but if you practice well, you'll be able to save time, right? Alternatively, here we can see the numbers are in arithmetic progression. Arithmetic progression means the numbers like having the common difference as same. Here 2, 2, 2, right? So what we can do, we can apply the concept of averaging, right? We know that there are total 24 numbers, right? 24 numbers will be formed from all these 4 digits by mutual arrangement, right? Now what is the biggest number that will be formed? That is 8, 6, 4, 2. And what is the smallest number that is formed? That is 2, 4, 6, 8, right? So this is the biggest number, this is the smallest number. If we find out the average, we will be getting average value of each number, right? Average value of each number, right? And this is the average value of each number, and such 24 numbers are there with us. So this will give us the sum, right? This is the average value till here. This is the average value of one number, and average value into 24, that means total numbers will give us the total sum. So this also can be done. So in that case, 8642 plus 2468, it's 12 over here, and we add this 8 plus 2 10, 6 plus 4 10 and 1 11, 6 and 4 10 plus 1 11, and 8 and 2 10 plus 1 11 into 12. So it's 1 1 1 1 into 120. So straightforward we'll be getting this answer, right? This is 20 into 6, 120 into 4 times 1, right? So this is all method is also applicable, but this is applicable when the digits are having the digits are in arithmetic progression. If they are not in arithmetic progression, we cannot get the average value of each number, right? So in that case, we cannot apply this funda. Okay, so the previous method will be applicable in that particular case. Suppose we are having the digits as 1 2 3 5 7, right? Suppose we have 5 digits, right? So we cannot apply this rule over here. Okay, so in this case, what you have to do, just see, these are 1 2 3 4 1 2 3 5 7. In this case there are 5 numbers, so by mutual arrangement we will be getting 120 numbers. 120 divided by 5, that is, each number will come at each place for 24 times. So the sum of each place, units place, tens place, and so on, we can get. So what that will be, it's 1 plus 2 plus 3 plus 5 plus 7, that is 7 plus 5 12 and 3 15 16 17 and 1 18, right? So 24 into 18 is the sum of units place. Just multiply this and get the sum of the units place, then write the unit digit and carry forward the remaining numbers and just add up as we have already discussed, right? The entire processing will take 1.5 minutes, but it's worth spending because the problem is so conceptual and so easy, right? So I hope you are clear with both the methods. And simultaneously, if we are having 1 2 3 5 6, suppose, then we can apply this method. I just do it once for you. Suppose I have the 5 digits as 1 3 5 7 9, right? Now I can form like a 5 factorial, that is 120 numbers from arrangement of these 5 digits. Now I have to find out the sum of all these numbers, that is all the 120 numbers. Obviously I cannot write all the numbers. Now the funda is, I'll just take the average value of one number. So the smallest number will be 1 3 5 7 9, and the biggest number will be this 9 7 5 3 1, right? So what's the sum? It's 0 7 and 3 10 and 1 11, 5 and 5 10 and 1 11, 7 and 3 10 and 1 11, 9 and 1 10 and 1 11. So this is the average. This divided by 2 is the average value of one number, and we have 120 numbers like this, right? So it's 2 into 60, right? So it's 11111 into 600 is the answer, right? This 5 times 1 and this 0 I shifted over here. So it's 11111 into 600. That will be the sum of all the 120 numbers which we are getting by arranging these digits, right? So the problem becomes very, very simple when we have the data in arithmetic progression. Okay, I hope you are clear. Similarly, let's take this question. The sum of the digits in the unit place of all the numbers formed with the help of 3, 4, 5, 6 taken all at a time. That means further we can make 4-digit numbers, right? And since we have to use each digit once, so the mutual arrangement will give us 24 numbers. That is 4 factorial 24 numbers. Now 24 divided by 4, 6 That means each digit will be coming at each place for 6 times, right? So we just have to find out the sum of the digits at the units place. So each digit is coming for the 6 times. So 6 times 3, 6 times 4, 6 times 5, and 6 times 6. So that is 6 times 3 plus 4 plus 5 plus 6, right? So it is 6 into 4 and 3, 7 plus 5, 12 into plus 6 is 18. So it's 108, right? So the sum of digits at the units place is 108, and we are asked that much only. So just mark the answer. I hope you are clear now. Friends, we have done good number of problems in this session. Do revise this session, and we'll meet you in the next session once again. Bye bye.